Good day to our respected lecturer, Dr. Logahin, and my fellow classmates from Occurrence 1. Today, I will be sharing with you on data collection strategies and some of the key findings I've figured out throughout the experiment. I'm Ooi Yew En, your host for today's presentation. Before we dive further into the main topics, let's talk about how are we going to interpret our data. Method of analysis ranges from observation analysis of variance, trend analysis, as well as cross-tabulation. However, each strategies are specific, which mean they are not general. In order to achieve the most relevant result, we must first identify the variable of interest in a particular experiment. Variable of interest can be defined as a changing quantity that is measured, or commonly known as the resulting variables. Now, let's look into details of these two classes of data analysis method, the qualitative and quantitative method. Qualitative analysis is the process of collecting, analyzing, and interpreting non-numerical data, such as changes in color of the solution. To ease your understanding, this method is observation-based. On the other hand, we have quantitative analysis, which is collecting and analyzing numerical data to describe, predict, or control the variables of interest. Without further ado, let's dive into our experiment, namely the titration and pH curve. Before that, let's take a quick look on the objectives of this experiment. Firstly, we need to determine pH curve for titration of strong acid with strong base and weak acid with strong base. Secondly, we need to understand suitable indicators for respective pairs of acid and base. Last but not least, we will develop necessary laboratory skills to be in chemistry-related profession. So speaking of our main topic here will be the relationship of pH with the increase of titrant. Therefore, the most suitable method we can use to analyze our data is cross-tabulation data. Basically, the data will be recorded in table form that is mutually exclusive and having connection with one another. In short, we can use it to perform categorical data, where the data can be divided into mutually exclusive groups. In this case, we can divide the data into columns. Say, the volume will reside on the left-hand side, while the pH will be on the right side. When we proceed further to the graph, we are able to observe the relationship between the pH value and the volume of titrant, which is sodium hydroxide solution in this case. This also allows us to determine the trends and patterns among the data collected. Let's use this graph as an example. From the graph, we are able to differentiate the little things just by comparing their shape. The vertical line on the left-hand side signifies the pH value in the range of 3 to 10, while the graph on the left has a significantly shorter vertical line, which determines a shorter range of pH, around the value of 6 to 10. With this, we are able to correlate the pH values with the suitable indicators in respective experiments. Nonetheless, cross-tabulation method allows us to compare and contrast between two separate data, so that we could observe the deviation between experimental and theoretical data. Such practice ensures us a higher accuracy in obtaining our results. Ultimately, here are a few key findings I would like to share to you. Firstly, remember to rinse the apparatus with distilled water, then the solution that you are about to fill with. Avoid holding the bulb of the pipette as it is very sensitive to temperature. Thirdly, always calibrate your pH meter with buffer solution of pH 4, 7, and 10. Last but not least, here's a little fact for you that sodium hydroxide is not prepared directly from its salt due to its natural ability to absorb moisture from the surrounding. That's all from me. Thank you for watching.